All right, guys, I'm going to work through the entire test review, and then in the next video, I'm going to work through the extra test review. So we get all the problems, the questions, everything answered, so you are ready for your test on Tuesday. So if we look at number 81, the first thing we're going to do is factor out the GCF. So they both have an x cubed in common. So we're going to factor that out, and that leaves us with 5x minus 12 equals 0. We set each piece equal to 0, and we get x cubed equals 0, 5x minus 12 equals 0. Well, take the cube root of each side. The cube root of 0 is just 0. Again, this is multiplicity. You have 0 3 times. We'll talk about that later. And then here we're going to add 12 to both sides. 5x equals 12. Divide both sides by 5, and you get x equals 12 over 5. So your two answers here are x equals 0 and x equals 12 over 5. So then we come to 83. We notice 83 has 4 terms. So we say, okay, how do we factor? How do we solve when there's 4 terms? Well, we look to group. We're going to take the first 2 and the second 2. What do we have in common with the first 2? It's going to be x squared, and we're left with x minus 7. In my second group, I can take out a positive 4, and I'm left with x minus 7 equals 0. So x minus 7 is going to come out in front by itself, and then x squared plus 4 gets its own parenthesis. And then to solve, we set each piece equal to 0. So x minus 7 equals 0, and x squared plus 4 equals 0. So when we go to solve, we add 7 to both sides, and x equals 7. And then over here, I'm going to subtract 4 from both sides. So I get x squared equals negative 4. Then I'm going to take the square root. I get x equals. When I take the square root of a negative number, I have to remember, ooh, wait a second. I think there's something special in there. That would be our I. So we're going to put plus and minus in front of our answer. The square root of negative 1 is I, and the square root of 4 is 2. So this would be plus or minus 2i. So I have my 3 answers here. One of them is real, and 2 of them are imaginary. So I look at 84. Same thing, there's no GCF, or is there? Oh, wait a second, there is. I look and I say, look, there's an x in every single one of these terms, so I can take one of them out. So I'm left with 9x cubed plus 27x squared minus 4x to the first power minus 12x. Obviously the x divides out, so we're just left with 12 equals 0. Don't get fooled by that, guys. Always look for the GCF. And now that we're left with 4 terms here, we're going to group. So I still have my x hanging out here out in front. What can I take out of 9x cubed and 27x squared? Well, I could take out a 9x squared, and that will leave me with x plus 3. What can I take out of negative 4x and a negative 12? I can take out a negative 4, and that will leave the x plus 3. So I still have my x out in front here. I have my x plus 3, and then I have 9x squared minus 4. And I say, oh, wait a second. I think I can factor 9x squared plus 4 a little more, because they're both perfect squares. So that leaves me with 3x plus 2 and 3x minus 2, all equal to 0. Then we set each piece equal to 0 and we solve. So my first x equals 0, that's one solution. X plus 3 equals 0 gives me x equals negative 3. 3x plus 2 equals 0 gives me x equals negative 2 over 3 when I solve. And then 3x minus 2 equals 0 gives me x equals positive 2 over 3 when I solve. And there's all 4 of my answers. Now I go to 85. 85 is a long question. I look at this and I say, okay, x to the 6. That means I have 6 answers for this problem. I should have 6 zeros. Whether they be real or imaginary, I should have 6. So this is a trinomial, so I'm going to look and say, can I factor this? What times what gives me x to the 6? Well, that would be x cubed and x cubed. What are the factors of negative 8 that multiply to give me negative 8 but add to give me negative 7? That would be minus 8 and plus 1, both equal to 0. Now, once I factor this, I notice that I have the difference of cubes in my first parenthesis and the sum of cubes in my second parenthesis. So this one, my A term is 1, and 1x, I should say, and my B term is 2. And in the second parenthesis, my A term is 1x, and my B term is positive 1. So when I factor this out, my difference in sum of cubes pattern, it would be x minus 2, and then I square the first term, x squared. I'm going to add A times B, so 2x, and then I square the last term, so it's going to be plus 4. My second pattern is going to be x plus 1. Then I'm going to square the first term, subtract A minus B, and then I'm going to square the last term, all set equal to 0. And now I look and I say, okay, well, what can I solve here? If I look at x minus 2, I set that equal to 0, I get x equals 2. That's a positive, real solution. I can say x plus 1 equals 0, so I set that equal to 0, I get x equals negative 1. That is also a real solution. But what I have left over as my trinomials, both of those are going to give me imaginary solutions because I can't factor them. Not necessarily going to be imaginary. I know they are because I've already worked it out, but neither of these factor. So you either have to complete the square or have to use the quadratic formula to get your answer. So I'm going to do both methods. I'm going to take my red trinomial here, and I'm going to complete the square. I have x squared plus 2x plus my square equals, I'm going to move 4 over to the other side, so negative 4 plus my square. So how do we complete the square? We're going to take our b term, which is 2, divided by 2. That gives me 1. So over here, I'm going to have x plus 1 squared. And then what goes inside of my box? Well, I'm going to square 1. So it's 1 here and 1 here. So negative 4 plus 1 is negative 3. Now we will take the square root of both sides. Remember, guys, when you take the square root, plus or minus goes in front of your answer. And there's a negative underneath there, so I'm going to take it out, and I have I root 3. The last thing we're going to do is subtract 1. So we have x equals negative 1 plus or minus I root 3. So here's 2 more answers over here. And then we'll do the same thing here. In this case, if you want, since my b term is not an even number, we can go ahead and use the quadratic formula. So I will have x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times 1 all over 2 times 1. So as we simplify, I have 1 plus or minus the square root of negative 1 squared is 1 minus 4 all over 2. So simplify a little more. 1 plus or minus the square root of negative 3 over 2. Again, I see a negative underneath, so I got to take out that I. So I have 1 plus or minus I square root of 3 over 2. And those would be my other 2 answers over here. So I have 2 here in green. I have 2 in blue. I have 1 real in red and 1 real in green. So that gives me my 6. That is a tough problem. There's a lot going on in that problem. We've got to really pay attention to what we're doing there. All right, in 86, this is another trinomial. This is x to the 4th. So when we have a trinomial, we try to say, can we factor this? Are there factors of x to the 4th that if I could split them up and gives me x, that gives me x to the 4th. So I could do x squared and x squared. And are there factors of 48 that would multiply to give me negative 48, but add to give me negative 13? Absolutely, that'd be minus 16 and plus 3. So I can then break down x squared minus 16 a little more, x plus 4, x minus 4. Since I have x squared plus 3, I know that does not factor, so I'll just have to go ahead and solve it and get an imaginary solution. So on this side, I have x equals 4. I have x equals negative 4. And here I'll have x squared equals negative 3. When I take the square root of both sides, I get x equals, again, when you take the square root, plus or minus goes in front. Because that's a negative underneath, we're going to take out that negative and have an I, and then the square root of 3 is left underneath. So here are my 4 solutions. I knew there was 4 because at the beginning, it was x to the 4th power. So then I come to 87. We've been working well, everything's going along good, and now we have 2 radicals. Usually, guys, when we have 1 radical, we isolate the radical, then we square both sides, we're good to go. In this case, when we have 2 radicals, we need to move 1 to the opposite side. So let's do that first. I'm going to go ahead and move square root of x minus 2 over. So I have square root of 2x plus 3 equals 2 minus the square root of x minus 2. And now that I have 1 radical on one side and 1 on the other, I can go ahead and square both sides. Because what we're trying to do is just end up with 1 radical. And once we do this, we will achieve that goal. So on the left, when you square a square root, you're left with 2x plus 3. And then over here on the right, what this says is 2 minus the square root of x minus 2 times 2 minus the square root of x minus 2. It's that binomial 2 times. You cannot distribute that exponent over a plus or a minus sign. So this 2x plus 3 is just going to kind of hang out over here, and then we're going to FOIL. So 2 times 2 is 4. 2 times negative square root of x minus 2 is minus 2 square root of x minus 2. Then I have the negative square root of x minus 2 times 2. It's going to give me another minus 2 square root of x minus 2. And then when you multiply, negative times negative is going to give me positive. When you multiply the square root times the square root, it cancels itself out. So that's what we're left with, is just x minus 2. So what can we combine on this side? Well, I have a positive. So we can go ahead and combine here. 4 minus 2 is going to give me positive 2. I have negative 2 and negative 2. Square root of x minus 2 is going to give me minus 4 square root of x minus 2. And then I have my plus x. Over here, I'm still going to have 2x plus 3 hanging out. So we can go ahead and subtract 2 from both sides, and we can subtract x from both sides, because what we're trying to do is isolate this negative 4 square root of x minus 2. So this will cancel. So we're left with x plus 1 equals negative 4 times the square root of x minus 2. The next step we're going to do is divide both sides by negative 4. So we're left with x plus 1 over negative 4 equals the square root of x minus 2. I'm going to go ahead and continue my work up here. But in order to get that radical to go away, we're going to square both sides. So guys, think about this. When we square both sides, when you square a square root, that just cancels out. So you're going to be left over here with x minus 2. But on the right-hand side, when you square the square root, this is saying x plus 1 quantity squared on the numerator, and then this is negative 4 squared on the denominator. So what this looks like is x plus 1 times x plus 1 over 16. So we're going to go ahead and FOIL that out. That's going to give me x squared plus 2x plus 1 over 16 equals x minus 2 over 1. At this point, I'd like to go ahead and cross multiply. So I'm going to say 16 times x minus 2 equals x squared plus 2x plus 1. And then distribute. So 16x minus 32 equals x squared plus 2x plus 1. And since this is a quadratic, we're going to go ahead and move everything to one side and then see if we can factor it. So I'm going to subtract 16x minus 16x, and I'm going to add 32, so plus 32. So that's going to leave me with x squared minus 14x plus 33 equals 0. So let's look at that and say, can we factor this? Well, what are the factors of 33 that could multiply to give me 33 and add to give me 14? Well, if you think about it, guys, you have x and x in the front. What about if I say negative 11 and negative 3? If I multiply negative 11 times negative 3, I get positive 33. If I add negative 11 and negative 3, I get what? Negative 14. So here we have x equals 11, and here we have x equals 3. So we do all this work, and we're so proud of ourselves, and we're ready to move on to the next. But what do we have to do, guys? We've got to make sure that when we check our answer, it satisfies the equation. So let's go ahead and plug back in real quick for x equals 11 and for x equals 3. Go back to the original. So we're going to take the square root of 2 times 11 plus 3 plus the square root of 11 minus 2. Does that equal 2? So 2 times 11 is 22 plus 3 is the square root of 25 plus 11 minus 2 is 9 equals 2. Well, the square root of 25 is 5 plus the square root of 9 is 3 equals 2. Well, that doesn't work. So x equals 11 doesn't work. Let's try 3. So I'm going to say the square root of 2 times 3 plus 3 plus the square root of 3 minus 2. Does that equal 2? So 6 plus 3 is the square root of 9 plus 3 minus 2 is 1. Does that equal 2? 3 square root of 9 is 3 plus 1 equals 2. 3 plus 1, 4 does not. We did all that work for my answer to be here, guys. No solution. That is a possibility on the test. You've got to make sure that when you, especially with these square root problems, work them out and make sure you check. The directions are going to say check for extraneous solutions, so make sure you do that. All right, moving on to number 89. Again, this is another solution. It's not an inequality, it's an equation, so you have to solve it. But you guys are going to have to know what to do. So we're going to have to first isolate this right here. So I'm going to add 25 to both sides. So I have x minus 1 to the 2/3 power equals 25. So how do we get rid of that 2/3 power? Well, the first thing I'm going to do is raise both sides to the 3/1. Well, I'm going to do that. Well, when I multiply a power to a power, 2/3 times 3/1, the 3's cancel. So I'm left here with just x minus 1 squared equals 25 to the 3rd power. It's a big number. I understand that. It's 15,625. And now I'm going to look at this and say, okay, now I have x minus 1 squared. You could write out x minus 1 times x minus 1, then move to 15,625 over. That would be crazy. Just go ahead, guys, and take the square root of both sides. So I have x minus 1 equals, when you take the square root, you have plus or minus in front of your answer. And the square root of 15,625 is 125. And then our last step is to add 1 to both sides. So you have two problems here. You have 1 plus or minus 125. This is 1 plus 125, and this is 1 minus 125. You have two whole number answers. Your answer is x equals 126, and you have x equals negative 124. Remember, when you have a plus or minus, you have to simplify both answers. Make sure you guys do that. Again, this problem here is going to work out to be ginormous. Are the numbers on the test going to be this big without a calculator? No. So don't freak out about this. But how do I get 3/4 to disappear, to cancel out? I'm going to multiply by the denominator. We talked about this. Not multiply, raise it to the denominator. So when I multiply 3/4 to the 4/3, this cancels. I'm left with just x plus 2 to the 3rd power equals 27 to the 4th power. You guys, I know, cannot do that. It's going to be 531,441. Again, you're not going to be expected to do that on the test. Relax. So now how do we solve this? The mechanics behind this is what we're looking for. What is the opposite of cubing a number? It's going to take the cube root. So what you do to one side, you do to the other. So here we're left with x plus 2, and the cube root of this large number happens to be 81. So the last thing we're going to do is subtract 2 from both sides. So we get x equals 79. Again, these large numbers, 27 to the 4th power, you guys are not going to see on the test. It's just the mechanics of how to simplify, how to undo the 3rd, 4th power, that sort of a thing. That's what we need to focus on. All right, I come to 91, and I realize this is a rational. Rational is just a grown-up way to say fraction. So what do we have to do? We have to find a common denominator. So I look at my denominators. There's nothing to factor. There's nothing to break down. So I look and I say my common denominator is going to be x times x plus 2. So I look at each fraction independently. My first fraction has the x. It's missing the x plus 2. So what you multiply to the bottom, you do to the top. My second fraction is missing both the x and the x plus 2. So what you do to the bottom, you do to the top. My third fraction has the x plus 2. It is missing the x. What you do to the bottom, you do to the top. And now that all three of our denominators are the same, we don't have to worry about them anymore. So I'm going to rewrite my equation of my numerator. It's 5 times x plus 2 equals x times x plus 2 plus 3 times x. And I tell my class all the time, anytime you have a rational, at the beginning of the rational question, you need to ask yourself, what values of x will make my denominator 0? So if I get them at the end, I say, oh wait, those don't work. So if, guys, you work this out and you get x equals 0 or x equals -2, you know that those solutions are extraneous. They're not valid because if you put 0 here, your denominator would be 0. If you put -2 here, your denominator would be 0. So those aren't valid. So it's just a good thing to have in your mind. But let's go ahead and solve. So I have 5x plus 10 equals, if I distribute here, I have x squared plus 2x plus 3x. So let's see what we combine on the right-hand side. I have 5x plus 10 over here on the left. I have x squared plus 5x. And since I have a quadratic, I have x squared and x. I'm just going to go ahead and move everything to one side. So I'm going to subtract 5x and minus 10. Subtract 5x and minus 10. So when I do that, I'm left with x squared. These cancel. Minus 10 equals 0. This does not factor. I can't break it down into difference of squares or anything like that. So I'm just going to go ahead and solve. X squared equals 10. Move it to the other side. Take the square root. I get x equals, when you take the square root of a number, plus or minus goes in front of your answer. And we can't break down 10. So it's just plus or minus the square root of 10. All right, so now we're coming to some absolute value questions. Absolute value is a little different. When we solve absolute value, we need to make sure you remind yourself you get your absolute value isolated completely by itself, nothing added, subtracted, multiplied, or divided. Then once you do that, you're going to set up two equations. You're going to set up your original, x minus 5 equals 10. Then you're going to set up an equation that is the opposite answer. So x minus 5 equals -10. So in both instances, we're going to add, pen's not working, add 5. So I get x equals 15. And over here, we're going to add 5. I get x equals -5. Now, before we just move on, and we're so happy with ourselves, we need to check. We need to check to make sure that both of our solutions satisfy the equation. So just mentally do it. 15 minus 5. Absolute value of 15 minus 5 is 10. 10 equals 10. We're good. -5. -5 minus 5 is -10. The absolute value of -10 is 10. We're good. Both satisfy the equation. So now we're going to move on. I'm not sure where my problem went. Number 95, so let me just write it in real quick. Sorry, 95 is the absolute value of x squared minus 3 equals 2x. So again, make sure your absolute value is isolated. It is. So we're going to write our two equations. X squared minus 3 equals positive 2x. And x squared minus 3 equals -2x. So in both cases, we're going to solve. It's a quadratic, so we're going to move everything to one side. Move this 2x over, it becomes negative. So x squared minus 2x minus 3 equals 0. If I were to factor this, factors of -3 that multiply to give me -3 and add to give me -2, it's going to be x minus 3 and x plus 1 equals 0. So x equals 3 and x equals -1. We need to go back and check, guys. When you go back and check this, x equals 3 satisfies the absolute value equation. X minus equals -1 does not, so you would cross it out. Same thing here. We're going to move this over. I get x squared. This is going to become positive 2x minus 3 equals 0. So my factors of -3 that multiply to give me -3 but add to give me positive 2 are going to be plus 3 and minus 1. So here I get x equals -3 and x equals 1. And when you plug these back into check, -3 does not satisfy the equation, but 1 does. So make sure, guys, on absolute value, square roots, rationals, everything, you go back and check your answers. So now let's look at 103. All right, 103 is an inequality. This is a linear inequality because it's set to the first power. So what we're going to do is go ahead and simplify each side, then move letters to the left and numbers to the right. So I'm going to go ahead and distribute. I have 3x plus 6 plus 7 is less than 2x minus 5. I can go ahead and add these two. So I have 3x plus 13 is less than 2x minus 5. I like to move letters to the left and numbers to the right. So I'm going to go ahead and subtract 2x and then subtract 13. We have not multiplied or divided by a negative number, so we don't have to flip our sign. So I get x is less than -18. We're going to have to write our answer on our test in interval notation. It might be helpful for you guys to go ahead and graph so you can kind of see what your answer looks like. I have my -18 here, my 0 here. It's just less than, not or equal to, so I'm going to have an open circle. When we have an open circle, we use parentheses. And it says x is less than, so I'm going to shade everything that is less than -18. So as we write our interval notation, remember we read from left to right. So it's going to start over here at -infinity, and it's going to go up to -18. It does not include -18, so that's why we use a parenthesis. If it included, we would use a bracket. Okay, coming to number 105, same thing, linear inequalities, the first power. I do see that I have a fraction, so you can go ahead and multiply through to get rid of the fraction if you want to, or you can simplify here as you want to. I'm going to go ahead and distribute. So I have 4 times 5 is 20 minus 8x less than or equal to 1/2 times 8 is going to give me 4 minus 1/2 x. Now I see I do have a denominator, so I'm going to get rid of it. I'm going to multiply everything by 2. So 2 times 20 is 40. Minus 2 times 8 is 16x, less than or equal to 2 times 4 is 8. And then this is where my denominator will cancel, so minus x. Now we're just going to move letters to one side and numbers to the other. So I'm going to go ahead and add x to both sides and subtract 40. So that leaves me with -15x is less than or equal. 8 minus 40 is going to give me -32, and this is going to cancel. So now, guys, if we're going to isolate x, we're going to divide by -15. When you multiply or divide by a negative number, your inequality sign flips. This becomes greater than or equal to. And you could just leave this as 32 over 15. So our answers need to be written in interval notation. So let's just throw it on a graph to kind of see what that looks like. Here's 0. We can say 32 over 15. We have a closed dot because it's or equal to, and it says all the values of x that are greater than, so it's going to be to the right. So our interval notation, reading from left to right, is going to start at 32 over 15 and go to infinity. And remember, on infinity, you always have parentheses, never, ever, ever a bracket. All right, starting with 107, I have an inequality that's absolute value. So again, we're going to have to solve this 2 ways. As soon as we realize that our inequality is isolated in our absolute value, we're going to write x plus 6, just rewrite it, less than 5. And then my other one is going to be x plus 6 is greater than, you flip the sign, and you flip the sign of the answer. And we go about solving. So subtract 6 from both sides. I get x is less than -1. Subtract 6 from both sides, and I get x is greater than -11. So I'm going to throw that on a number line and see what it looks like. I have -11 here, -1, and 0. Both of them are open dots because it does not say or equal to, and it says x is less than -1, so that would be this way. And the other one is greater than -11, so it's this way. So where do we overlap? Right there in the middle. My interval notation would be -11 to -1, and there are parentheses because it does not include that value. All right, scooting along here to 111. Again, if we have a quadratic inequality, we need to treat it as if it were an equation. You got to move everything to one side, And then once we do that, we can say, oh, okay, well, wait a second. This says less than, that's an and problem. It's an open circle because it is not included. It doesn't say or equal to, so that means we're gonna shade in the middle. And then we're gonna use parentheses on our notation because the values are not included. So now we can go ahead and factor. What are the factors of 27 that are gonna multiply to give me negative 27, but add to give me negative 6? That's gonna be x minus 9 and x plus 3. So x equals 9 and x equals negative 3. Those are our key points that we're gonna put on our graph. So we have negative 3, 0, and 9. Again, at the beginning, we said they were gonna be closed values, and it was an and problem. Oh, I'm sorry, both open, my bad. Sorry, both open because it's not or equal to. And we said we're gonna shade in the middle. So these guys, you gotta make sure you check. I colored or I shaded over 0. If I shaded over 0, then 0 should satisfy the equation. So if I plug 0 in here and here, negative 27 is less than 0. That is true. So my solution would be from negative 3 to positive 9, and it does not include either of those values. That's why we have our answer in parentheses and not a bracket. And now we're going to move to 111. Again, 111, I have 3 possible answers here. We've got to make sure that we check all of the situations and see what works and what doesn't. So I have everything on one side, zeros on the other, so I can now say, all right, I'm going to treat this like an equation. Well, what do they have? All right, what can I factor out? I can factor out they both have an x and a 5. So I'm left with x squared minus 9. So here I have x equals 0. Here I have x equals plus or minus 3. If I move 9 to the other side, take the square root, or if I factor to x plus 3x minus 3, that's where I got that from. So my key points are going to be at negative 3, 0, and positive 3. It's just less than, not or equal to, so all of these are open. And at this point, guys, you have to test points to see what satisfies the inequality. I'll shade it. I have a section here. I have a section here. I have a section here, and I have a section here. All of these areas I need to check. So I'm gonna go ahead and plug negative 4 in my yellow region, we'll call it. I'm gonna plug in negative 4. So if I say 5 times negative 4 cubed minus 45 times negative 4, is that less than 0? So this is gonna give me 5 times negative 64 plus 180, is that less than 0? It's going to be negative 320 plus 180, is that less than 0? And yes, that value is going to be less than 0. So over here, this area of numbers will work from negative infinity to 3. So now let's check a number in the red section. Let's go ahead and pick negative 1. That would be easy. So 5 times negative 1 cubed minus 45 times negative 1, is that less than 0? So negative 1 cubed is negative 1 times 5 is negative 5 plus 45, is that less than 0? Is 40 less than 0? No. So this area doesn't work. So let's pick a number in the blue area. Do it in this color blue. Let's pick positive 1. So 5 times 1 cubed minus 45 times 1, is that less than 0? 1 cubed is 1 times 5 is 5 minus 45 less than 0. Is negative 40 less than 0? Yes. So this area works. And then let's pick positive 4. So I have 5 times 4 cubed minus 45 times 4. Is that less than 0? Well, 4 cubed is 64 times 5. This is not going to work over here. That is not going to work. So where are the sections that work? It's going to be from negative infinity to negative 3, and then from 0 to 3. So the way you would write that would be negative infinity to negative 3, both with parentheses. Union, that's how we say and in math, 0 to 3. None of those values are included or have a specific stopping point, so that's how you would write it. All right, guys, next thing I'm going to do is the additional review. I will post that video probably tomorrow because I can barely talk anymore right now. So that's good for tonight. Just keep practicing, practicing, practicing. If you can do all this stuff on your own, you'll be good for the test.